Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about elements and their classification. In this session we are going to say about an important attempt for the classification of elements which was done by Mendeleev. So we call that Mendeleev's classification of elements. The classification of elements made by Newland on the basis of atomic mass was continued by Dmitry Ivanovich Mendeleev, a Russian scientist. So he continued classifying the elements based upon the atomic masses of the elements. Just like the Newland how he did based upon the atomic masses of the elements, in the same way Dmitry Mendeleev also continued to classify the elements based upon their atomic masses. He observed that when elements are arranged in the increasing order of their atomic masses, the properties of the elements repeated at certain intervals. Means the properties of one element are being repeated by some other element when the elements are written in the increasing order of their atomic weights. He gave his observation in the form of a law known as Mendeleev's periodic law. We can say this was the first periodic law given on the basis systematic arrangement of elements and classification. That we say as Mendeleev's periodic law. It states that the properties of the elements are periodic functions of their atomic masses. That means the properties of the elements are being repeated at regular intervals of time from element to element when these elements are written in the increasing order of their atomic masses or atomic weights. So when elements are written in the arranged in the increasing order of their atomic masses or atomic weights, the properties of the elements are being repeated from one element to another element. That is called periodicity. So the properties of the elements are periodic functions of their atomic masses. This law is known as Mendeleev's periodic law. When Mendeleev arranged the elements in the increasing order of their atomic masses, the elements with the similar properties were placed in the same column. So he arranged all the elements in the increasing order of their atomic masses. Then while writing like that, one element's properties are being repeated or resembled with certain element other element in that continuity. So that element is written down to the first element and continue to arrange the remaining elements in the increasing order of the atomic masses. In this way, the elements with the similar properties were placed in the same column and a table was prepared which is called as Mendeleev's periodic table. This is one of the successful points in this Mendeleev's classification. He could classify all the available elements at that time into a table, into a periodic table. He could arrange all the available and known elements at that time into this periodic table. We can say this is the first and successful periodic table. Mendeleev's periodic table it is. Okay. A periodic table is a chart representing the systematic arrangement of elements into vertical columns and horizontal rows, such that elements with similar properties fall in the same column. Okay, a periodic table represents the systematic arrangement of elements in the vertical columns and periods. There, the elements present or placed in a vertical column will be having similar properties from one to another. In that way, he arranged all the available and known elements at the time into the table called periodic table. In the honor of his name, it is called Mendeleev's periodic table. This we say as Mendeleev's periodic table. In this way, he classified all the elements into this tabular column as vertical columns and horizontal rows. What he did here? He arranged elements in the increasing order of their atomic masses. Hydrogen, next helium, and next lithium. Actually, lithium properties are resembling with the properties of hydrogen. So it is written down to lithium hydrogen again. And it is continued to write the elements in the increasing order of their atomic masses. and after writing certain distance, after neon, sodium is coming. And here, sodium is also having similar properties with lithium and hydrogen. So it is written down to the lithium here. In this way, the elements which are having similar properties are written in the same column, one down to another. Okay. This is called Mendeleev's periodic table, having horizontal rows and vertical columns. Now let us see the explanation part about this periodic table. That we say as characteristics of this Mendeleev's periodic table. In this, the vertical columns in the periodic table are called groups. See here, there are 8 vertical columns. These vertical columns in the periodic table are called groups. There are 8 groups. These are numbered from 1 to 8 in the Roman numbers. See here, this is the first group, second, third, until 8. Totally there are 8 groups in this Mendeleev's periodic table. They are designated with Roman numbers 1 to 8. And here, if you observe, each group from 1 to 7 are divided into subgroups A and B. Isn't it? See, first group is subdivided into A and B, second also, third till seventh group. All these 7 groups are subdivided into 2 subgroups, A and B groups. Thus, there are totally 15 vertical columns that constituted 8 groups. Totally there are 8 groups. And in these 8 groups, first 7 groups except 8th group, first 7 groups are divided into 2 subgroups A and B. So totally these are 14 and plus 8 group 1. Totally there are 15 columns constituting majorly 8 groups. And these horizontal rows are called as the periods. Okay, vertical columns are called groups, horizontal rows are called periods in this table. There is gradual change in the property of elements from metallic to non-metallic along the period from left to right in this periodic table. If we observe at the extreme left side of this periodic table, metals are there. And as we move from left to right in any period, metallic properties are transmitting to non-metallic properties. Means metallic properties decreasing, non-metallic properties increasing. If we observe this second period here, what is the first element? Lithium, beryllium. So these are metals. As we move from left to right, if we observe carbon, nitrogen, oxygen, fluorine, non-metallic elements are there. This highly non-metallic element, highly metallic element. What happened here to the property? As we move from left to right, metallic properties decreasing, non-metallic properties increasing in any period from left to right. Okay, that is given here. The property of elements from metallic to non-metallic along the period from left to right. It is changing from metallic to non-metallic property. Okay. Next, the advantages from this Mendeleev's periodic table. Let us see here. One among them is a systematic study of elements made easy from this Mendeleev's periodic table. Mendeleev's periodic table simplified the study of elements because he categorized all the available elements into different groups. So, if you know the properties of one group, those can be applied for the elements in that group. So, it made it easy to remember the properties of elements. It became useful in studying and remembering the properties of a large number of elements in a simple way. This is because the elements showing similar properties belong to same group. So all the elements having similar properties kept in one group. Now if we know the properties of one of those elements, the same properties can be applied for all the remaining elements in that group. In that way, it is made easy to remember the properties of all the elements. Need not to remember the properties of all elements present in a group. If you know the properties of one element in that group, the same properties can be explained or can be applied for the remaining elements in that group. In that way, the remembrance of the properties of elements made easy by this Mendeleev's periodic table because elements are grouped here. The elements with similar properties are classified as one group. Okay. Next, prediction of new elements. Yes, by this classification, Mendeleev predicted some elements, some unknown elements. While arranging the elements in the increasing order of their atomic masses, Mendeleev left some blanks, around three blanks for elements that were not discovered at that time. So he assumed as certain elements to be found still, and he left certain blanks for those unknown elements which are to be found later. He was able to predict the unknown elements more or less accurately also. Not only leaving the places, he was able to predict those unknown elements and their properties also. In that way, he succeeded there. He named those unknown elements as Eka boron, Eka aluminum, and Eka silicon. He named them so as they were just below boron, aluminum, and silicon in the respective subgroups. So he left a blank down to boron in the periodic table, and he assumed that element also will show the similar chemical properties just like boron. That's why he called that unknown element as Eka boron. See here, he predicted some elements, he left some blanks in his periodic table, and he predicted the properties of those elements also. So he was succeeded in predictions in these predictions more or less accurately also. Okay. So he named them so as they were just below the boron, aluminum, and silicon in his periodic table respectively. Later, this Eka boron was later named as scandium, and Eka aluminum was named as gallium, and this Eka silicon was named as germanium after their discovery. So in this way, he succeeded by leaving certain gaps in his periodic table. He assumed that as certain elements to be found and should be filled in these gaps. And even not only leaving the gaps, he named those elements also before their discovery. And even he predicted their properties also before their discovery. And he was succeeded in these predictions more or less accurately. So this is one of the advantages of Mendeleev's periodic table and Mendeleev's periodic classification. And one more, correction of atomic masses. Mendeleev's periodic table helped in correcting the atomic masses of some elements based on their positions in the periodic table. So based upon the properties and characteristics, the positions of the elements are fixed in the periodic table. Based upon their positions, the atomic masses of certain elements were corrected by Mendeleev. For example, atomic mass of beryllium was corrected from 13.5 to 9. So earlier it was expected as its atomic mass 13.5. But after placing this boron in the periodic table, this beryllium in the periodic table, its atomic mass is corrected to 9. In the similar way, the atomic masses of indium, gold, platinum were also corrected based upon their positions in the Mendeleev's periodic table. Earlier, they were assumed some other, but after placing them into the Mendeleev's periodic table based upon their positions in the periodic table, their atomic masses were corrected. This is one of the advantages from this Mendeleev's classification and table. Even though it is having many advantages and it has given complete clarity about the classification and properties of elements, there are certain defects in this Mendeleev's periodic table also. Let us see what are those here. One, it is position of hydrogen. As we have seen in the periodic table of Mendeleev, there are two positions for the hydrogen. The position of hydrogen is not corrected and defined. That is why it is placed in two positions. It is still not certain whether to place hydrogen in group 1 1A or 7A, because hydrogen possesses certain properties which are similar to 1A group elements, and it also possesses certain properties which are similar to that of 7A group elements. That is why the position of hydrogen is not fixed yet. It is having two places in the Mendeleev's periodic table, one in the 1A group, one in the 7th A group, because hydrogen exhibiting the properties of these two group elements. So that is one limitation or drawback we can say in the Mendeleev's periodic table. Another one is anomalous pairs of elements. Anomalous, nothing but being different from the remaining. In Mendeleev's periodic table, the elements are arranged in the increasing order of their atomic masses. Isn't it? This table is designed based upon the increasing order of the atomic masses of the elements only. But some pairs of elements were placed such that elements with the higher atomic masses were placed prior to those with lower atomic masses. So at certain pairs of elements, he couldn't follow his periodic law. That is, writing all the elements in increasing order of the atomic masses. But he wrote the remaining all elements as it is, as per his periodic law. But at a certain pairs of elements, he couldn't follow his principle. So there he wrote the element with the higher atomic mass first and followed by element with lower atomic mass. So those pairs of elements where he couldn't follow his periodic law are called anomalous pairs. For example, argon was placed before potassium, whereas its atomic mass is more than that of potassium. We know the atomic mass of argon is 40, whereas that of potassium is 39. So actually as per the atomic masses, potassium should be written first and then it should be followed by argon. But in the Mendeleev's periodic table, argon was placed before potassium. So in this case, the periodic law is violated. What is this periodic law? Writing the or arranging the elements in the increasing order of the atomic masses. But yet this pair of elements, argon and potassium, this periodic law is violated. These pairs of elements where Mendeleev's periodic law violated are called anomalous pairs of elements. Let us see those anomalous pairs here. One it is, as we told now, argon and potassium. Another one is cobalt and nickel. One more, tellurium and iodine. If you observe here, the second element is having lower atomic mass than the first element. But in the Mendeleev's periodic table, it is written first, followed by element with lower atomic mass. This is just to fit these elements in the remaining elements in that group. Actually, if potassium is written first as per the atomic mass, potassium will be in the group along with the other elements like neon, krypton, xenon, helium, and these all elements. These all elements are noble gases as we know, but potassium is not. So to avoid that inconvenience in the property, dissimilarity in the properties, instead of potassium, argon is written along with those elements and potassium is written in the first group along with the lithium sodium elements which are having similar properties with potassium. So as per the potassium chemical properties, he violated his periodic law, that is writing the elements in increasing order of atomic masses. So that we can say as one of the limitations or drawback in the Mendeleev's classification. The same it is in this case of remaining pairs also. See, first element is having greater atomic mass than the second one. In the same way, they are placed or arranged in the periodic table. So this is violation of periodic law. Next, grouping of elements. This is also one of the limitations or drawback in the Mendeleev's periodic table. Certain chemically dissimilar elements are have been grouped together. For example, elements of group 1A such as lithium, sodium, potassium are grouped with dissimilar elements such as copper, silver and gold. See here, these all are metals only, of course. These all are present in the 1A group. But if you observe, the elements lithium, sodium, potassium. These elements are very highly reactive metals. They participate in the chemical reactions vigorously, isn't it? Whereas if you observe these elements, copper, silver, gold, these are least reactive metals. Even these metals like silver and gold, they exist in the nature free, in the free form. So these are least reactive metals. So but these least reactive metals and highly reactive metals all are placed in the same group. Group is meant to represent the elements of similar properties. But here in one group there are elements with the dissimilar properties. So this also made certain confusion. It is made inconvenience in remembering and understanding the chemical properties of the elements. This also we can say as one of the drawbacks in the Mendeleev's periodic table. And as we told, wrong order elements. In the case of anomalous space, we told this. Mendeleev placed many elements in wrong order of their increasing atomic masses in order to place elements having similar properties in the same group. We told in just in case of argon and potassium, he violated his periodic principle, periodic law. So instead of writing potassium at first, he wrote argon in the column along with other elements helium, neon, krypton, xenon. Because this argon is having similar properties with those elements. Even though it has higher atomic weight, he wrote this first to potassium. So this we say as a wrong order of elements. So this also considered as one of the drawback in the Mendeleev's periodic table. Yes, as we told example here, atomic masses of nickel is less than that of cobalt. One more example they have given here. Nickel and cobalt. The atomic mass of nickel is less than that of cobalt. In spite of that, cobalt is placed before nickel. Atomic mass of chromium is 50.2 and the atomic mass of vanadium is 50.9. See here, which is having lower atomic mass? Chromium. So it should be written first. In spite of this, chromium is placed after vanadium. Means first vanadium is written, then chromium is written. So this is a violation of periodic law which was given by him. So as per the law, first chromium should be written, it should be followed by vanadium. But according to their chemical properties, to keep the elements the similar properties in one column, he wrote vanadium first, followed by chromium. The same here also, nickel and cobalt. Okay, here actually nickel should be written first, but he arranged cobalt before nickel in the periodic table to make the elements with the similar properties in one column. Okay, these we can say as violations in the periodic law, wrong placements. So in spite of these all limitations and anomalies, the Mendeleev's periodic table was one of the wonderful discoveries because it was the first time arranging all the available elements in one periodic table and identifying the similarities between the chemical properties of the elements and they are arranged in the different groups. Okay, this we can say as one of the wonderful discoveries, even though it has certain limitations and drawbacks. Okay. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today and visit our website aimstoday.in for latest updates and recorded videos.